Alright, welcome to Academic Diaries class. In our last class, we treated sets, and we said that sets is the collection of numbers, elements, events in an orderly manner. Now, this collection of events, the pattern to which it is collected, or the pattern that differentiates one element moving to the other, is what we call sequence. So a sequence is simply the arrangement of numbers in pattern. So when you have to show that this one comes before this to this to this, that's sequence you're talking about. And under this sequence, we have two categories that you need to pay attention to before we start talking about types. We have what we call the finite sequence. We have what we call the infinite sequence. Another name for sequence is progression. Anytime you're given a sequence question, you need to be checking if it stops with dot dot dot. Let's say, for example, if I have A, B, C, D. If it stops here, then the nth stem, AN, is this. Very important. Let's say we have A, B, C, D, dot 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 G. Then the nth stem is this. But if we have a sequence, let's say A, B, C, D, the nth stem, we don't know it. So it runs continuous. That's an infinite sequence. So that one that we know the last stem. So another name for this is last stem. We call it the nth stem. So, but that one we don't know the last stem that runs continuous is called infinite sequence. It's important you note this. Now under sequence we have what we call series. And we define series as the sum of a sequence. So when instead of having A, B, I come and see A plus B plus C plus D, dot dot dot, this is an infinite series. Then if I see A plus B plus C plus D, this is a finite series. So finite series, infinite series. So going forward, we now need to talk about two major things. Just like, for example, we can have a sequence that says 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81. So we can have a sequence like this. So it's a sequence. It's just sequence of the squares of the natural numbers. So whenever you have a one-to-one correspondence with the natural numbers, we'll talk about sequence. One-to-one correspondence such that I can say that this is E1, this is E2, E3, third term, fourth term, fifth term, sixth term, seventh term, eighth term, ninth term. I'm using E to mean the number of terms. So let's move to the two major types of sequence. Remember I said this is category. It's very important because if you don't pay attention to this, your questions will be having issues. So types of sequence. We have two major types. We have the AP, which we call arithmetic progression or arithmetic sequence. And we have the GP, which we call the geometric progression. which we call the geometric progression. So let's treat arithmetic progression, AP. I normally tell my students that an AP or an arithmetic sequence is a type of sequence that subtracts the first term from the second term, comma, the second term from the third term to get a common difference. So it's a type of sequence that subtracts the first term from the second term from the third term to get a common difference. That is, A2 minus A1 should be equals to A3 minus A2, and it should give you a common difference. So the common thing here is common difference. Or you can also define it as the type of sequence that adds its common difference to given term in order to get the next term. So let's say first term is A1. If I add the common difference to the first term, I should get the second term. And if I have the second term, if I add the common difference, I should get the third term. So that is AP for you. And we normally have what we say, we normally have what we call the number of terms. So we say is the nth term of an AP. And the nth term of an AP, En, is simply given by E plus n minus 1 d. Remember that the first term is always constant, is E. Well, let's check it. E1 equals to E plus, where I see n, I put 1 minus 1 d, 0 d. Anything times 0 is that thing. So E1 will always be E. So it's constant. E1 will always be E. So for that reason, we can say that when we have E2, instead of memorizing the formula, let's just take it that it is E plus D, which is the same thing as saying E plus 2 minus 1 D, which is E plus 1 D, which gives you E plus D. So when I have E3, it's just the same thing as saying E plus 2D. E4 is just E plus 3D. E5 is just E plus 4D. So if I know this, what of the sum of the nth term? Sum means, sum of the nth term is simply, if I have E1, E2, E3, E4, if they tell me find the sum of the first 4 terms, by the time I sum this up, it should give me the Sn, the sum of the fourth terms, the first 4 terms. So this sum of first 4 terms is given by the equation, that is, remember that what we did here is the nth term of an AP. So for sum of the Sn, the sum of the nth term of an AP, we have it by E1 plus En, then n over 2. And remember I told you that En, another name for En is last term. When we know the last term, n over 2 into E1 plus En. But remember that En is equals to e plus n minus 1d. So for that reason, Sn is equals to n over 2 into e1 plus, where we see en, we replace it with this value, e plus n minus 1d. So if you simplify now that this is n over 2, e plus e, e1 is the same thing as e, so you have 2e plus n minus 1d. So I said you use this one when en, or another name for an is last term or nth term, last term is known. For example, I have a, b, c, d. I come and see dot 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 h. This is my an, is known, so I'll use it. But let's say I have, you use this one, use this when en is unknown. So let's say, for example, I have a, b, c, d, dot dot dot. You see it? So for infinite sets, for infinite sequence, I use this. For finite sequence, I use this. So this is the importance of knowing the difference between finite sequence and infinite sequence. So if I know this, that's for sum of nth term of an AP. Now for geometric progression, let's go to geometric progression. Geometric progression. I normally define this geometric progression to my students. I normally tell them that geometric progression is a type of progression or sequence, a type of progression that multiplies. The difference between it and the other one is addition, this one is multiply, that multiplies the given term by given term with the common ratio, or by the common ratio to get the next term. This, I'm brushing the handwriting, just pay attention. So I said it's a type of progression that multiplies the given term with the common ratio to get the next term. Or we can say it is a type of progression or sequence that divides the second term by the first term, comma, the third term by the second term to get a common ratio R. So you can clearly see that is for geometric progression, the type of sequence that divides the second term by the first term, the third term by the second term to get a common ratio. That is A2 divided by E1 should be equal to A3 divided by E2 to get the common ratio. That is geometric progression for you. And now, if you know this geometric progression, you need to know what we call the nth term of a geometric progression. And the nth term, I'm using En, of a geometric progression, the nth term of a geometric progression is simply given by Er raised to power n minus 1. So we know that A1 is always A. Let's check it. A raised to power R 1 minus 1 is going to be AR raised to power 0. And anything raised to power 0 is 1. So A times 1 is the same thing as A. A will always be A. So the geometric progression and the arithmetic progression, they have the first term in common, which is A. But second term, notice that arithmetic progression is A plus D in second term, while geometric progression is A times R, AR in second term. So it's the same thing. The other one is A plus the difference. This one is A times. I told you they have geometric is multiplication. The other one is addition to get the next term. So that means that the second term of a geometric progression will be A2 equals to AR. That is AR raised to power 2 minus 1 equals to AR raised to power 1. And anything raised to power 1 is the same thing. So the third term of a geometric progression is going to be AR2. So as it's progressing, you are reducing. So the fourth term will be AR3. So much here over here. AR3. And that is for the nth term. So this is for finding the nth term of a GP. What about finding the sum? So sum of a GP. To find the sum of a GP, we make use of the formula Sn equals to A into R raised to power n. It's almost the same thing, but instead of putting it on top, you now do minus 1 all over R minus 1. And please note, you only use this formula when your R is greater than 1. Let's say you've done A2 divided by A1 equals to A3 divided by A2, and what you get as your R is greater than 1. You use this formula. But if you've done the common ratio and what you get is like 1 over 2 as your common ratio, 1 over 2 is 0.5, is less than 1. That means the formula you will use is going to be A into 1 minus R raised to power n all over 1 minus R. Very simple. So this is the first. This one is for when R is less than 1 or when 1 is greater than R. So this is the second formula. First formula. Then there's what we call sum to infinity. Sum to infinity. And we make use of these two formulas. When they say the sum to infinity, you simply use sum to infinity is equals to A over 1 minus R. When 1 greater than R or R less than 1, you use this. But you can do sum to infinity equals to A over R minus 1. That is when R greater than 1. Very simple. So with this, you are good to go on the introductory part of sequence. So in our next class, we'll now solve problems related to sequence. So this is everything we did today. So, and most important thing I want to highlight is the part where students don't pay attention to finite and infinite sets. Once they see a question they want to solve, it determines a lot about your answer. When I have an expression that is in this form, I won't treat it the way I treat the one that is in this form. So it's very important you pay attention to all these things. So with this said, our next class will just solve problems on that sequence. Just like if I tell you, okay, now next class we'll treat all these things. So thank you for your time.